Good afternoon, everyone. Welcome to our science class. I am your teacher, Sir Jason. For this afternoon, we will be discussing about the physical properties of a gas. So stay tuned for our science lesson for today. So as we start, let's go over the objectives of our lesson. So at the end of the lesson, I should be able to first identify the physical properties of a gas. Second, explain how the properties of a gas relate to kinetic molecular theory. And lastly, explain the importance of accuracy and consistency in solving problems. So before we start formally our lesson, let us watch this video that will give us an overview of the different properties of gases. Now, before we play the video, please take note of the different properties of gases that will be discussed in the video. So let us play the video for the introduction of the nature of gases.
When I think of gases, it's easy for me to think of a balloon. The balloon itself isn't a gas, it's rubber. But inside the balloon are gas molecules. The air we breathe is made of different gas molecules, mostly nitrogen and oxygen, but there are some trace amounts of other chemicals like carbon dioxide. These gases don't just sit around. Gases are very energetic and they bounce around like crazy. Gases have a lot of kinetic energy. And kinetic means motion, so gases move a lot. According to kinetic theory, all matter is made of tiny particles that are in constant motion, even solids and liquids, but gases move the most. It's simple enough, but there are some assumptions that are made. With gases and the kinetic theory, these few assumptions need to be understood. First, the particles of a gas are treated as hard, perfect spheres with insignificant volumes. This means that between the particles of a gas, there will be lots and lots of empty space. These particles are also moving in constant, random, and rapid straight-line paths. They only change their direction when they collide with an object or particle. And the third assumption is that all collisions between particles in a gas are perfectly elastic, meaning no energy is lost. It's merely transferred during a collision. Let's apply this to the balloon. The molecules bounce into each other without reacting in elastic collisions. The particles also bounced against the walls of the balloon, which exerts a pressure on the sides of the balloon. The air on the outside of the balloon also exerts pressure on the balloon, and we call that atmospheric pressure. Gas pressure results from the force exerted by a gas per unit of surface area on an object. But if there are no particles of a gas, there can be no pressure. In this case, we've got a vacuum. A vacuum is an empty space with no particles and no pressure. Pressure that results from collisions of atoms and molecules in the air with objects is called atmospheric pressure, and it occurs in all directions. We can measure atmospheric pressure using a barometer. This particular type is filled with mercury. Don't drink it or breathe it. It's actually really dangerous. So why use it? Well, mercury is the densest room temperature liquid, which makes it possible for the barometer to be less than 1 meter high. If it were made with water, it would need to be over 11 meters high, which is about 34 feet, and it's also really inconvenient. So a mercury barometer can be much smaller, about 30 inches high. At the top of the barometer is a vacuum, and the atmospheric pressure, all the atmosphere from Earth's crust to space, is pressing down on the liquid in the basin. When the atmospheric pressure rises, the mercury adjusts to the increasing pressure by moving up the tube. This creates equilibrium between the internal and external pressures. When the atmospheric pressure decreases, the mercury level drops to maintain equal pressure. This kind of barometer is read in millimeters of mercury because it measures the change in height of mercury inside the barometer. But this isn't the only measure of pressure. No, that would be too easy. In addition to millimeters of mercury, there are pascals, which are actually usually measured in kilopascals and are the SI unit of pressure. There are atmospheres, or ATM, where 1 atmosphere is standard. And lastly, the torr, which is basically just another name for millimeters of mercury, so go ahead and forget about it. Now you can convert between the different units very easily. You just have to know what the standard pressure is for each of them. So at STP, millimeters of mercury is 760. You need 101.3 kilopascals and 1 atmosphere. So to convert between each of them, we need to use a little bit of dimensional analysis, and let's just try something. Let's say you had a pressure of 825 millimeters of mercury, but you need the units in kilopascals. Start with what you're given and put kilopascals as your answer units. Knowing that there are 101.3 kilopascals, millimeters of mercury is 760, you can set up a conversion factor. Cancel your units, do the math, and you get 110 kilopascals. Pretty easy. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter at SciencePet.
Okay, going back. So, I hope you've learned something from the video. Now, I would like to ask a few questions. These are all related to the video you have just watched. So, my first question is, what were some of the properties that were discussed in the video? So, what were those properties of gases that were discussed in the video? Okay, let's see. Okay, so there are actually three properties discussed earlier. No? So first property is that gases are composed of different molecules. So these molecules are actually elements, composed of elements. Now, what were those elements mentioned? So we have oxygen, we have also nitrogen, and there's a compound which is not a basically it's a compound, but it's also a molecule. So we have carbon dioxide. So of course we know that oxygen is an essential gas because our body needs it. No? Now, the second one, the second property that was discussed in the video is that gases are very energetic. What does it mean? The molecules, since they are spaced very far from each other, so they have this what we call kinetic energy, in which kinetic means it's an energy in motion. So in other words, gas molecules are very mobile compared to the molecules found in solids and liquids. So that is what we mean by energetic. So in that case, the movement of the gas molecules are they move very freely. No, so they move at a slow rate or a rapid rate depending on the surroundings. Now we will have a further discussion of that one later. Lastly, another property to discuss is that these particles or molecules of gases exert pressure. So first is that the previous one is that they contain kinetic energy. Now that kinetic energy is translated into temperature, and on the other hand, we also have pressure, wherein these particles of gases exert pressure. For example, in that case, the balloon, the air or the gas inside the balloon exerts force towards the edge or towards the balloon. That is why when we try to inhale air or try to put air in a balloon, we get the balloon gets bigger because of the pressure that pushes the walls of the balloon altogether. Okay. Now, how about the different principles behind the kinetic molecular theory? There were three of them were discussed. Okay. Now, let us go over. Thank you for that one. So let us go over the different principles underlying the kinetic molecular theory. So first, we have that all collisions between particles are perfectly elastic. So I pretty sure you remember it in your grade 9, the different types of collisions. No? So what happens in a elastic collision? When we say perfectly elastic collision, the molecules, after they collide, they separate from each other. No? That's it. So that's for the first principle. The second principle is that particles of a gas are treated as hard, perfect spheres with insignificant volumes. No? That is why one of the main properties of gas is this what we call pressure. It's because when particles of gases uh, are are colliding, then they exert this particular force that actually exerts the force then exerts pressure on the object they're occupying. In that case, the balloon. So the balloon expands because of the pressure that is exerted on it by the gases or the gas molecules. Now, the third principle would be in gases, the motion is rapid and constant and random in a straight line path. So in the path in this sense is that it's always straight. No, there's no in gases in the movement of gas molecules. There's no such thing as curved path. So it's a straight path. Okay, so those are some of the principles underlying the kinetic molecular theory. So basically, this is just an overview of the lesson, no, that we will have this afternoon. Okay, so before we begin our series of activities, let us go. Let us have this very quick energizer first. Okay, so let me go over to the next part of our lesson. So let us play a game first. So I'm pretty sure you're familiar with this image. No, this is an app. No, way back. Just to share, way back in when I was in college. No, my classmates are very fun of playing of this. Very fun of playing this one. No, it's called Four Picks One Word, and I'm pretty sure some of you are so familiar with it. Now, for a game, the instruction is very simple. So you just have to guess the specific word that fits with the theme of the photos presented. So for each word, I will be there will be four pictures. Then you will try to guess what the pictures are pointing to or what is the theme of the picture. Now, just a hint, just to give you a hint, all of the pictures are pointing to the different concepts that we will discuss this afternoon, and some of them were actually presented in the video earlier. Okay, so let's proceed. Are you all ready? So if you're ready, then let's begin. Let's go with the first word. Okay, what do you think is the answer of this one? That's 1, 2, 3, 4, 5, 6, 8 letters. And the pictures are, it seems obvious, no, the answer to this one. Okay, anyone? Okay, the correct answer is pressure. Correct. Excellent on that one. Next picture. This one is very familiar, very obvious. Okay, what's the answer? Absolutely, the correct answer is we have temperature. All right. Next word we have. Okay, this one is very familiar. Okay, the first picture alone already says something. Okay, very good. The correct answer is volume. And the last word for this game. Okay. I've also mentioned about this one earlier, so I'm pretty sure we'll get this one very easy. Okay. Okay, the correct answer is we have molecules. Very good. Excellent answers, my dear students. Okay, now let us go to our first activity. So, for us to get to know better gases, I will be giving you some different some situations, and after analyzing the different situations, answer the questions that follow. So, are you now ready to explore the different situations? There are actually four of them, and I want you to carefully analyze each situation as I we will be exploring rather we will be exploring the different properties of gases through these situations. So are you ready? Okay, glad to know that. Let's proceed. Okay, so first situation 1. So as shown in table 3.1, there are three balloons. Now the table will be shown later on. So one balloon is deflated and the other is inflated, and both are weighed using a weighing scale with three different trials. In each trial, the measurement of the inflated balloon will be subtracted to that of the deflated balloon, and the total will be measured by getting the average measurement of the three trials. Now, let us check the table. Now, for you to analyze the data, I will be giving you 2 minutes to analyze the table carefully. Okay? So, your 2 minutes will start now. So, kindly take note of the differences in the masses of the balloons. Okay, I was a little nervous there. Let's just wait for this to turn off. Okay, now that you have already analyzed the data, I will have some questions in the next slide. Okay, let me go to the next slide. Okay, so first question is the mass of the deflated balloon different from the mass of the inflated balloon? Now, it's basically a yes or no question. Okay, what is the answer? Okay, yes. No, that's correct. No, it's a yes. Definitely, no, there's a difference between the mass of the inflated balloon and the deflated balloon. Now, let's go to the second question. Which is heavier, the inflated or the deflated balloon? And why? Okay, let me see. Okay, that's correct. No, so we have basically or obviously the heavier balloon is the inflated one. Now, why? It's because that's correct. No, it's because the inflated balloon rather has a heavier mass compared to the deflated balloon. So basically, when we blow air inside the balloon becomes heavier. Now, the next question would be, what specific physical property was presented in this situation? Now, I hope that you have taken note of the particular property that was shown earlier in the table. Yes, that's correct. No, the correct answer is it's mass. So basically gases have mass as well, just like solids and liquids. And lastly, what can you infer from this activity? Or what could be the possible what is the implication of this activity? No. Okay, that's correct, no? It means that gases also have mass, just like solids and liquids. Okay, let's go over to the next situation. Situation number 2. So a mixture of water and oil was poured inside a graduated cylinder. The water settled at the bottom while the oil on top. The air is introduced in the mixture using a pipette. As shown in table 3.2, the initial measured volumes of the water plus oil are indicated in the second column, while the total volume when air was introduced is indicated in the third column. Each trial is repeated thrice, and then for each trial, the measurement of the total volume of mixture with air will be subtracted to the volume of mixture without air. Okay, now let me show you the table for this situation. So I want you to carefully analyze the table found in the next slide. You have 2 minutes to analyze, and then after 2 minutes, you will have to answer the questions that follow. Ready? Okay, your 2 minutes starts now. Okay, let's just wait for this annoying sound to disappear. Okay. Okay, now you have already analyzed. I hope you have analyzed the data already. And let's go over to the questions to this situation. Okay, question number 1. What happens to the volume reading of water oil when air is introduced? What did you observe to the masses, or the volume rather? You're already done with mass, so we're already in volume. So what did you observe to the volume on the volume reading? Anyone? Yes, that's correct. No? So basically, the volume increased, when air was introduced. Okay, let's go to the second question. What does it indicate? So what is the indication of the activity or the situation? So there was an increase. What does it mean? Anyone? Okay. It means that gas has volume. No? So gas has volume because when gas was introduced to the mixture of the water and oil, the volume increased. So in other words, gas also possesses volume aside from mass. Okay. Third question. What specific physical property was presented in this situation? So I've already mentioned it. Okay, correct. The correct answer is it's volume. Okay, I hope you're learning something, class. Okay, let's proceed to the third situation. Okay, crushed ice is added to a 150 ml of water inside a beaker with an initial air temperature of 20 degrees Celsius. Then the beaker is heated for 5 minutes. Refer to table 3.3 for the readings. Once again, I will be giving you 2 minutes to observe the data. Okay, your 2 minutes starts now. Okay, now I hope you have already analyzed the data. And let's go over to the questions. Okay, so the first question is there a difference in the temperature of the air among the three setups? So basically, it's just a yes or no question, so I'm pretty sure you already know the answer. Okay, what is it? Yes, that's true. No, there's obviously a difference in the temperature of air among the three setups. Next question. Explain the difference in air temperature. Now, this might require a little bit of thinking, little bit of thinking time. So I will be giving you a few seconds to try to think about the possible factor that explains the difference in the air temperature. Okay. Now, do you have now the idea on the factor that could have caused the differences in air temperature? Okay, what is it? Excellent. So we have the flow of heat. No? So basically, heat is the reason why there is a difference in the air temperature. Now, as you know, we actually this is part of your grade 9 lesson. No? That heat actually flows. Uh, there's a mechanism in which heat flows. No, so in this sense, the heat flows from the system. Now, what is the system here? So as you have noticed, there's water in the water in the water, and then there's crushed ice inside the water in the beaker. No? So that is a system. Now, the heat basically flows from the system to the surroundings. So the surroundings, of course, the air that surrounds it. No? Now, if the water is cold, the water is cold, it's because of the crushed ice. Now, when the water is cold, then the surrounding environment would also be cold. And in the same way, when the beaker was heated, no, the surrounding air is also hot, or in other words, it's warm because of the warm system. The system again is the beaker with the water. So basically, that's the explanation why there is a difference in the air temperature because of the flow of the heat. Okay, thank you for that one. Now let's go to the third question. What specific physical property was presented in the situation? Now, have you noticed the unit that was used in the situation? Yes, that's correct. The answer is it's temperature. No? So we have already discussed the three different properties of gases. First we have the mass. Second one we have the volume. The third one is the temperature. Okay, let's go to the last property of gases. Okay, so observe the setup on the next slide. So identify what causes the balloon to inflate over the course of time as the water is being heated using a candle. Okay, I want you to analyze carefully the picture in the next slide. Okay, your 2 minutes starts now. Okay, now let's go over the different questions. Okay, first question would be what happened to the deflated balloon? So what happened to the balloon that was put above the beaker containing the water in the candle below? Okay, yes, that's correct. So basically, the deflated balloon became inflated. Now, what could have possibly caused this phenomenon? Anyone? Okay, the correct answer is yes, that's true. No, the correct answer is because of the flow of the heat, just like what was discussed in the previous situation. So now the heat flow is the reason why the balloon became inflated. Now the third question would be what is the function of the heat? Okay. Anyone? Let us see if you, let's try to analyze the function of the heat in the situation. So where do you think, first, before we get to the question, no, where do you think the heat comes from? Correct. No? So the heat comes from the candle, from the lighted candle. So basically the heat comes from that candle. And then what happens? What happens next? So the heat basically is flowing from the candle towards the water in the beaker. And what happens to the water in the beaker? Yes, that's correct. No, so the water in the beaker boils basically, no, because of the heat coming from the candle. Now, fire from the candle rather. So once the water boils, what happens? No, it's just like when we try to boil water from the kettle. No, when the water boils from the kettle, no, basically we see, what do we see? What do we see when we try to boil water from the kettle? We see, yes, that's correct. We see water vapor. Now, where do you think that water vapor went? The water vapor went to the, yes, of course. No, that's correct. The water vapor basically went to the balloon, inside the balloon. And that is the reason why the balloon inflates, because of the water vapor, no, or the steam that comes out from the boiling water. Okay. So that is the reason why the heat is the one that causes the balloon to inflate, because of the flow of the heat. No? So from the balloon to the boiling water, and eventually, rather from the candle to the boiling water, and eventually to the inflating balloon. Okay, let's go to the fourth question. What will be the temperature inside the balloon as it inflates? Okay, so what could be the possible temperature? Is it cold? Is it warm? Yes, that's correct. No, excellent. That's correct. Now, the correct answer is that, of course, it is warm, because it's coming from the water vapor. Water vapor coming, or the steam coming from the boiling water. Okay. And lastly, what will be the water level inside the apparatus over the course of heating? Okay. So what do you think will happen to the water level inside the beaker? Anyone? Yes, that's correct. That's an amazing observation, no, and an amazing inference rather, no. So it means that because the water boils, obviously the water level would go down, no? Because the water turns into steam, and eventually that steam will fill out the balloon because of pressure. That's correct. Thank you for these wonderful observations of yours, my dear students. Okay, so I hope you've learned something from the activity. Now let us go over the properties of gases. Now I'll just give you a run through of the different properties, because the activities have already introduced you to these different essential properties of gases. So of course, a gas is a collection of particles in constant, rapid, random motion, which is sometimes referred to as Brownian motion. So as you can see in the image, no, on the right, you can see that the molecules of a gas are rapidly moving inside the container. So gas particles constantly undergo collisions. No, as what has been mentioned in the video earlier, the type of collision is perfectly elastic. No. Now, gas particles constantly undergo collisions with each other and with the walls of the container, which causes the change in direction, hence the term random. No? It's because since the gas is contained in a particular container, then the movement of the gases becomes limited. Thus, they move in a random manner. Okay, that's what was being observed in the fourth situation that was presented just moments ago. Okay, let's go over the different properties of gases. These were already mentioned earlier, and let us see these four properties and their units of measurement. So we have pressure, temperature, volume, and the number of molecules. Now, the number of molecules could also mean the mass of the gas. Okay. Now, the pressure is measured in PA. Now, what is PA? PA means Pascal. No? Pascal is the standard unit for measurement of pressure. Now, we also have other units which we will discuss later on. Next, we have temperature measured in K. What is K? Yes, it's Kelvin. And then volume. Of course, we all know the measurement of volume, the standard measurement for volume, it's in liters. And lastly, the number of molecules in a gas. And this one is discussed in your grade 9. This one is measured in terms of mole, no? Mole. And sometimes, when we try to refer to the mass of the gas, we refer to the mass in grams, correct? Okay, let's go over the different examples of these properties. So for temperature, for example, when air temperature is released from the rice cooker, it starts to boil and the warm water vapor escapes. No? Now, in this manner, no, when we try to put our hand near the rice cooker, no, we can actually observe that our hands would feel warm. It's because of the escaping water vapor, and that is what we mean by temperature. Because the boiling water is warm or hot in this sense, no, meaning the surrounding environment would also be hot. That is why temperature is one important property of gases. Okay. Let's go over to the next property, pressure. Okay, I'm pretty sure you always encounter this one, especially when you try to open a soft drink bottle or a can of soft drinks. No? Now, when you open a can or bottle of a soft drink, it fizzes because of the escaping dissolved carbon dioxide due to the change of pressure. When the wind blows, it exerts pressure too. Okay. No, so say for example, no, when you are near the beach, no. So when you're near the beach, usually when the breeze comes to us, no, we can actually feel the pressure of the wind coming towards us, no. It's because of the movement or the direction of the wind. So basically, the wind carries the gases that comes towards us, and then we can feel the pressure because we are actually going against the direction of the gas. Okay, that is why we feel the pressure. Okay, next. No? The soccer ball is filled with air. So this is now for volume and mass. So our example here is a soccer ball that is filled with air. So it bounces while you are dribbling it. No? So because obviously we can also dribble a soccer ball. So any ball that has air inside it can be dribbled. No? The same is true with other kinds of balls. So for example, basketball, volleyball, tennis ball, baseball, yes. No? So take note that balls have different masses once they are deflated or inflated. No, of course, no. When we try to remove air from a ball, then we expect that when it becomes deflated, it becomes what does it? It becomes lighter compared when it is inflated. No, so that is why volume and mass are also very important properties rather of a gas. Okay, so now you have understood better these properties. Now let us go over the units of measurement. So for volume, we already know that it's in liters, and sometimes we also use cubic meters or the symbol M with a cube. No, and the numbers of particles are usually described in moles or in mole. Now, yes, no, that's correct for volume. So its main unit of measurement is in liters, and but sometimes you can also use cubic meters. But more often, no, we use liters. Now, for temperature, gas temperatures are often measured with thermometers that report temperatures in degrees Celsius. Now, scientists generally use Kelvin temperatures for calculations. Now, when we try to calculate the temperature of gases, we do not usually use Celsius. Rather, we use Kelvin. Now, how do we convert Celsius to Kelvin? Now, here's the conversion factor. No? So, when we, okay, let us look at this table. No? It's a comparison of the three temperatures. So, we have in Celsius, in Fahrenheit, and we have in Kelvin. No? So when a substance is in its freezing point, or basically this is water, no? Because the freezing point in water is of course 0 degrees Celsius. Now, if we convert it to Kelvin, the equivalent temperature in Kelvin is in 273.15 Kelvin, no? And then for boiling point, of course, we know the boiling temperature of water is 100 degrees Celsius. And so, when we try to add 100 degrees Celsius to 273.15 Kelvin, so we get 373.15 Kelvin. So basically, the formula is that we add, for us to get the temperature in Kelvin, we just add the degrees in Celsius plus 273.15. Okay. Any questions? Okay, I hope you have understood that one. Let's proceed to the next one. Okay, so I have discussed already this one, no? So basically, when we try to get the temperature in Kelvin, we add 273.15, and when we try to convert back to Celsius, just have to subtract the temperature in Kelvin with 273.15 for us to get the temperature in degrees Celsius. Okay, let's proceed to the next property. Pressure. So to understand gas pressure, picture a typical gas in a closed container. So just like the image that you see here on the right, the upper right corner. So each time a gas particle collides with and ricochets off one of the walls of its container, it exerts a force against the wall. The sum of the forces of these ongoing collisions of gas particles against all the container's interior walls create a continuous pressure upon those walls. Hence, pressure is the force divided by area. So let us remember this one. Pressure is the force divided by the area. Okay, let's proceed to the next one. Now, for us to compute pressure, no, so we have pressure equals force over the area. And when we talk about equation for the gas pressure, we have gas pressure is equal to the force due to particle with walls and the area of the walls. Now, what wall are we exactly talking about here? So, it may refer to any container. Say, for example, a balloon. So, the walls of the balloon or the walls of a beaker or any container wherein we trap air or a gas inside it. Okay. Now, the accepted international system of units measurement for gas pressure is the Pascal. No, I have already mentioned that one earlier. So, a Pascal is a very small amount of pressure, so the kilopascal is more commonly used. Now, remember this term earlier in the video? Yes, no? So, what are the other units of measurement? So, we have the atmosphere, the torr, the millimeter of mercury, and bar. Now, the millimeter of mercury is more commonly used in the medical world. No? When we say millimeter of mercury or mmHg, that is what we are trying to measure in terms of the blood pressure. No? So, or that's the unit for blood pressure, the mmHg. And what is the standard or the normal blood pressure for humans? We have, yes, that is 120 over 80. Okay. Now, here are the relationships. No, you have already observed that one in the video, so I guess I don't need to expound this one anymore. So, because I believe you have already taken down notes. Okay. Next. So, the numbers in these relationships come from definitions, so they are all exact. So, at sea level on a typical day, the atmospheric pressure is about 101 kilopascals or about 1 atmosphere. So, in calculations, the variables P, T, V, and N, or the number of moles, are commonly used to represent pressure, temperature, volume, and moles of gas. Okay, now let us go to Boyle's law. Now, I believe you have already taken up this one in the previous module. Actually, this is module 1. No? So, let us try to see the relationship between volume and pressure in this sense. No? So, as you can see, when volume is decreased, what happens to the pressure? Can you look at carefully the image? So, when volume is decreased, what happens to the pressure? Okay. Any observations? Excellent. No, the correct observation is that when volume decreases, the pressure decreases. No? So when volume decreases, pressure increases. So What kind of relationship is that one, by the way, in math? Oh, I'm pretty sure you've discussed that one in math. That is, anyone? Yes, that's correct. No, that is what we call inverse proportion, or inverse proportionality, or inversely proportional. No? So that's the relationship between volume and pressure. Now take note that when we try to compare volume, or the relationship between volume and pressure, there is one thing that should be kept constant, and that is what the temperature should be. The temperature should be kept constant in this manner. Okay. So I have already mentioned this one in previously, just moments ago. No, thus we can say that gas pressure and volume are inversely proportional. No, and it expresses as P alpha 1 over B if N and T are constants. Take note that the number of moles and temperature should be constant. So in other words, the observation that the pressure of an ideal gas is inversely proportional to the volume it occupies if the number of gas particles and the temperature are constant is the statement of Boyle's law. No? So in Boyle's law, we have this principle that when volume decreases, the pressure increases, and vice versa. Okay, I guess you already have an idea of this one because of the previous module. This is basically just a recap of the Boyle's law. Okay, let's proceed to the next law. Okay, now this is just a representation of the Boyle's law. No? So as you can see in the image, no, so we have the pressure. The pressure is there. So when we try to increase, no, when we try to increase the pressure, what happens to the what we call this one? What happens to the volume? The volume will decrease. No. So when we try to increase the pressure, the volume decreases because of the inversely proportional relationship between temperature and pressure. Okay, how about this one? The second one is the Charles law. This was in your module 2. No? Now, what relationship now is explored? No? The relationship is between volume and temperature. Now, this time, the one that is kept constant is the pressure. So, when we add heat to a particular system, no, when we add heat to a particular system containing gas, no, the temperature increases because of the volume. Now, why? It's because the gases will have more room to move freely, and thus because their movement becomes more unrestricted. So, in other words, when temperature increases, the volume also increases, and vice versa. When we decrease the volume, we also decrease the temperature. So through this, we can say that the gas pressure and temperature are directly proportional, expressed as V alpha T if N and P are kept constant. So earlier, in Boyle's law, we have the temperature that is kept constant, and this time for Charles' law, that the pressure is kept constant. So for an ideal gas, the volume and temperature as described in kelvins are directly proportional. So if in Boyle's law, the relationship is inversely proportional, for Charles' law, the relationship is directly proportional. Okay, now so you already have the idea of the difference between Boyle's law and Charles' law. Aside from, of course, the units of measurement or the factors that are being considered, we also have the type of relationship. So again, what is for Boyle's law? For Boyle's law, we have the inversely proportional relationship, and for Charles' law, we have the directly proportional relationship. Okay. Now, okay, so we also have the same representation, just like that of the Boyle's law. Okay, now so let us have a quick review. Okay, so just have a quick review of the different properties of a gas. Okay, so identify the properties of a gas that are being described. Okay, let us go over the items. Let's go to the first one. Okay, the space occupied by a gas. What property is described here? Anyone? Excellent. The correct answer is... Okay, let us reveal the correct answer. The correct answer is volume. Excellent answer. Okay, next item. Forces of gas particles striking the walls of the container. Anyone would like to answer? Absolutely, that's correct. No, the correct answer is that's pressure. Okay, next. The kinetic energy of molecules. Okay, what we are trying to depict here when we say kinetic energy of molecules? Yes, that's correct. No, so the correct answer is we have temperature. Next, we have number 4 for sorry. Anyway, no. Yes, the correct answer is mass. So anyway, already I had a moment of what do you call this one, a spoiler alert. No. So let's go to the next item. 273.15. Remember this unit? What is the unit being measured here? We have... Okay, the correct answer is temperature. That's correct. Now, let's go to the sixth item. Warm 5 ml of water. Now, take note that for this item, we have two answers. We have two answers for this item. No? So, what is the first one? Okay, when we say warm, what does it mean? Or what does it measure? Correct. That's for the temperature. How about for the 5 ml? We have the 5 ml is for volume. Correct. So there are two answers, temperature and volume. Okay, for the next items, we have for number 7 to 10, we have the units of measurement, and kindly give me the properties of the gas being described or asked in the item. For number 7, we have Pascal. What is the answer? That's correct. We have for pressure. How about for number 7? Number 8 rather. Atmosphere. Yes, correct. That is still pressure. For number 9, Kelvin. What is Kelvin in this situation? Of course, Kelvin is the unit for measuring temperature. And lastly, we have mole. What is a mole? A mole is of course a measurement for... What is it? Yes, that's correct. We have the mole as the measurement for the number of molecules, or we can also refer to this one as the mass of the gas. Okay. Now, I hope you have learned something, no? But before we end our discussion this afternoon, let me ask this very important question, no? Especially right now in our situation, no? Why is it important for us to be accurate and consistent in solving problems? No, because in our next lesson, no, we will try to solve different problems applying the of course applying Boyle's law and Charles' law, and also applying the relationship between the different properties of a gas. Why is it important for us to be accurate and consistent in solving problems? Anyone? Okay? Yes, that's correct, no? Now, it is important for us to be accurate and consistent in solving problems because, especially in the scientific world, no, we have to be very precise. We have to be very accurate with measurement because anything in excess becomes a mess or becomes a mistake. No, it becomes a mistake that in, for example, in the medical world, no, if we try to measure anything in excess, no, it might be very dangerous to a patient, no. In this manner, no, when we talk about measurements, may it be solids, liquids, or gases, no, when we talk about measurement, we need to be accurate and precise, and we have to be consistent. It's because if we make a mistake in solving those problems, in trying to determine the amount of something, no, it might lead to disasters or mistakes. That is why it's very important for us to be accurate at the same time to be precise and consistent in solving problems. No? So, in the scientific world, we have to be very careful with anything we do, especially when we try to solve problems, because in science, one of the main concerns in science is that the things that we are actually doing in science is that we are trying to solve different problems in our world today. No, especially that we are in we are in the coronavirus 19 pandemic right now, and although we are now in the stage of vaccination, no, we still have to be cautious, no, and our learning still happens at home, and so I do hope that you'd also try to apply what you have learned in your daily lives as well as in your homes, no. So I hope you have learned something for this afternoon, and thank you very much for tuning in and for taking your time to listen to our lesson for this afternoon. Now, for our assessment, I would like you to go to your quizzes app, or if you don't, if you have not downloaded the app yet, kindly go over to this website. Okay, so let's go over for the quiz. So kindly go to myquiz.com and type the following code 4421299. Kindly take a screenshot or kindly take a picture of this one, and then I will be setting the quiz and starting today. It's afternoon. So today afternoon, and I will be closing the quiz tomorrow afternoon as well. So yeah, you have a day to answer the quiz. Okay, are there any more questions or clarifications for our lesson this afternoon? None? Are you really sure? None? No more questions? Okay, let's call it a day. Thank you everyone for tuning in, and I do hope that you have learned something for today. Once again, this is Sir Jason Madronero, your science teacher, and see you in our next lesson. Goodbye everyone!